Hello and welcome to the free CCNA CyberOps instructor training, brought to you by the Open University Cisco Academy Support Center and the Institute of Coding. My name's Kevin Large. I'll be your instructor for this session. Well, it is the 2nd of December 2019. That big guy with the red suit and white beard and podgy belly is about to descend down chimneys and bring people lots of presents and stuff like that. Christmas is upon us already. Wow, unbelievable. Hello Anders. Hello Ed. Well, it is now chapter 11 of the free CCNA CyberOps instructor training. 2 more chapters to go. Wow, incredible. I'm feeling good, Carlos. Thank you very much. Yes, sorry I had to knock it on the head on Monday of last week. I'd completely overdone it and made myself quite ill with various other things that were going on, and lack of sleep for about 3 or 4 days in a row had finally made its toll. And yeah, I just couldn't do all 3 in one night. I wouldn't have made any sense. I'm not sure how much sense I make anyway, but I'd have made even less sense. Okay, yeah, good old Father Christmas. You know, the best presents are sometimes the ones you buy yourself if you're a techie. Like, I bought myself a couple of 34-inch 21 by 9 aspect ratio Dell monitors. That was a present from me to me. Yeah, superb. Yeah. Okay, now, we are now on chapter 11. So we're looking at security monitoring. We've got a reasonable amount to cover, so we probably had better crack into it. First thing we need to talk about is common monitoring protocols and associated protocols which are of use for when we are monitoring. So we're going to start off with Syslog and NTP. So Syslog, system logging, this is used for logging event messages from network devices such as routers, switches, firewalls, intrusion detection systems, intrusion prevention systems, and also endpoints such as servers and potentially even desktop computers. Whereas NTP, or Network Time Protocol, is a protocol which is used to make sure that we have very accurate time on all of the devices across our network, which is of course essential to logging, because if our logs are not time-stamped properly, then they will not hold up in court. You can say, well, look, we've got a log here. It says that this IP address broke into this device and did that at this time, and that IP address can be traced back to this person. However, if the times are all wrong on it, that person can say, I was down the pub having a pint and playing darts with my mates, and you can't prove it. So the time has to be up to date and accurate. Now, a Syslog server would typically listen on UDP, so that's a user datagram protocol at the transport layer on port 514. Syslog servers may indeed be a target for our threat actors, so hackers may block the transfer of data or tamper with the log data, or even tamper with the software that creates and transmits the log messages. However, we have enhancements which are provided by Syslog NG, or Syslog Next Generation. Let's have a little look at how we set up a Syslog server in Packet Tracer just very quickly. Okay, so we have Packet Tracer up and running. All I'm going to do is I'm going to get a 2911 router, a 2960 switch, and we'll have an end device which we want to make a server, because the server actually has the capability of working as a Syslog server. And then what we will do is we will wire those up using copper Ethernet straight through cables. We'll go from gigabit 000 into gigabit 001 on our switch, and from gigabit 02 to the network interface card on our server. We will need, of course, to put some IP addresses on these devices. So as it's a server, we'll configure a static IP address of 192.168.10.1 with a /24 subnet mask. No real need for a default gateway because we're not really going to be leaving this subnet, but what I will do is I will make the default gateway the IP address of the router. So if we ever did need to leave the subnet, we'd be good to go. I'll make that the highest IP address in the subnet, 10.254. Okay, get your students in a habit of checking everything once they do it. So we'll do an IP config to make sure that we have our subnet mask, IP address and default gateway. We'll now go into the router and we'll configure the router. The little arrow, when you drag it across the window to expand it, is sometimes like a hairline. It's almost like a trigger. It is. You can be almost on it and then not quite on it. What I will do is I'll just give the router a host name. You should always give your routers host names. And we will set up an IP address on the interface which is connected to the switch, which was gigabit Ethernet 00. I have noticed this with the latest version of Packet Tracer, Packet Tracer 7. Packet Tracer. This isn't the latest version, 7.21. Yes, I'm on my Linux machine. I put 7.2.2 on my Windows machine. I don't always get the little tooltip. I'm wondering if perhaps I got it switched off in the preferences. I won't worry about that now anyway. I know it was gigabit 00 that I used to connect. If you hover over the router you can actually see the interfaces, so I'm pretty certain it was gigabit 00. The easy way to tell, of course, would be to go into the interface and say no shutdown, and if the light goes green you're in the right interface. Okay, so we'll do an IP address of 192.168.10.254 with a subnet mask of 255.255.255.255.0. Right. It's already getting to the point where poor old Kev's brain's addled. There we go. And a no shutdown. I already did a no shutdown, didn't I? Okay, so first thing we'll do, we'll send a ping across from the PC to the router just to make sure I've got a good connection, which I have, so that's good. And then what we'll do is we'll go into services, and you can see that we do actually have Syslog. Syslog is on by default. We have no messages going across. We'll configure the router so as it sends Syslog messages to the Syslog server, and what we'll do is we'll have a little look at something. I just want to check something actually before I do that. Yeah, let's set the service timestamps for the log. So service timestamps log to date time milliseconds. Okay, this will make sure that our timestamps for our Syslog server are accurate down to milliseconds. And then what we will do is we will say login, and we can literally just type in the IP address of our Syslog server at this point in time. Provided we can ping it, it will actually log to it. So we obviously need IP connectivity, but once we've got IP connectivity we're good to go. Syslog server's on .1. At that point we can set what we call the trap, so that's login trap, and on a real system you would actually have 8 levels here ranging from 0 to 7. We'll see those in a moment. Those levels would run from emergency through alert, critical error, warning, notification, information and debugging, which is level 7, but we only have the option in Packet Tracer to do the last one, which is debugging. So this is the actual level of detail that Syslog will actually send to the Syslog server. Debugging basically sends pretty much everything. So when you set a level, what it will do is it will debug at that level and all of the levels below that. So this will debug from level 7 all the way down to level 0. If I set level 4, it would only debug levels 4, 3, 2, 1 and 0. Okay. Now if I come out of the interface by hitting Ctrl Z, you will see that I really hate that mouse sometimes. There we go. We are now logging to 192.168.10.1 on UDP port 514. Syslog. If we go into a Syslog server, we can actually see our Syslog messages popping up. This is a level 5 message. So Syslog is a relatively straightforward thing to set up. NTP, Network Time Protocol. Syslog messages are usually timestamped using the Network Time Protocol, and the Network Time Protocol also operates on UDP, User Datagram Protocol, on port 123. Now NTP will allow us to synchronize all of the devices on a network, end devices and network infrastructure devices, to a common time source. This is a local MTP server, which is also synchronized back to an authoritative time source, which will be a super accurate NTP server, what they call a Stratum 0 server, out on the internet. This allows all of our devices to have precisely accurate and consistent time. Because the events that are connected to an exploit can leave traces right across every network device in their path to the target system, we need to make sure our timestamps are accurate. Threat actors may indeed attempt to attack the NTP infrastructure in order to corrupt time information used to correlate the logged network events. So this can serve to hide the traces of ongoing exploits. Indeed, threat actors have even been known to use NTP systems to direct distributed denial of service attacks through vulnerabilities in client and software client and server software. DNS. DNS is used by many different types of malware. The DNS, of course, is the domain name service, and this is in use by literally everybody every day. Whenever you visit a web page by URL, you are making use of DNS in order for the system to find the IP address that that URL belongs to. Now, because DNS is in use by so many people every day, organizations may have less stringent policies in place to protect against DNS-based threats than they have to protect against other types of exploits. So attackers have recognized this, and they commonly encapsulate different network protocols within DNS in order to evade security devices. DNS is now used by many different types of malware. Some varieties of malware will use DNS to communicate with their command and control servers and to exfiltrate traffic, exfiltrate data in traffic disguised as normal DNS queries. So different types of encoding, such as base 64, 8-bit binary, hex, can be used to camouflage the data and evade basic data loss protection measures. Hypertext Transfer Protocol and Hypertext Transfer Protocol Secured. We have to bear in mind both of these widely used protocols have issues. However, Hypertext Transfer Protocol, which is the backbone protocol of the World Wide Web, this is a protocol where information is actually carried in plain text from source computer to destination on the internet. HTTP does not protect the data from alteration or interception by malicious parties. So it's a serious threat to privacy, identity, information, security. All browsing activity should be considered to be at risk. Indeed, there is a common exploit of HTTP which is known as an iframe or inline frame injection. Most web-based threats consist of malware scripts that have been planted upon web servers. These web servers can direct browsers to infected servers by loading what's known as iframes. In an iframe injection, the threat actor compromises the web server and plants malicious code which creates an invisible iframe on a commonly visited web page. Now, when this iframe loads, the malware is downloaded, frequently from a completely different URL than the web page that contains the iframe code. Network security services, such as Cisco's web reputation filtering, can detect when a website attempts to send content from an untrusted website to the host, even when it's sent as an iframe. HTTPS will add a layer of encryption to the HTTP protocol by making use of what's known as Secure Sockets Layer, or SSL. This makes the HTTP data unreadable as it leaves the source computer until it reaches the server. Unfortunately, the encrypted HTTPS traffic complicates network security monitoring. Some security devices will include SSL decryption and inspection. However, this can present processing and privacy issues. In addition, HTTPS adds complexity to packet captures due to the additional messaging involved in establishing the encrypted connection. If we have a little look, HTTPS, with its use of Secure Sockets Layer and Transport Layer security, adds considerable complexity in the establishment of sessions, and this can cause issues with packet captures. If we have a little look, you can see just how complex and many stages there are with our HTTPS transactions. Email protocols. So we have protocols such as SMTP, Simple Mail Transfer Protocol, used to send emails, POP3, Post Office Protocol version 3, and IMAP, which are used to receive emails. These can also be used by threat actors to spread malware, exfiltrate data, or provide channels to malware command and control servers. So SMTP sends data from a host to a mail server and also between mail servers. Similar to DNS and HTTP, it is a very common protocol to see leaving the network. Because there is so much SMTP traffic, it's not always monitored. However, SMTP traffic has been used in the past by malware to exfiltrate data from the network. In fact, back in 2014, the hack of Sony Pictures, one of the exploits used SMTP in order to exfiltrate user details from compromised hosts to command and control servers. This information may have been used to help develop exploits of secured resources within Sony Pictures network. Now, security monitoring could reveal this type of traffic based on the features of the email message. IMAP and POP3 are used to download email messages from a mail server to a host computer. So for this reason, they're application protocols that are responsible for bringing malware to the host. Security monitoring can identify when a malware attachment enters the network and which host it first infected. With retrospective analysis, we can track the behavior of the malware from that point forward. In this way, malware behavior can be better understood and the threat identified. So security monitoring tools may also allow the recovery of the infected file attachments for submission to malware sandboxes for further analysis. ICMP. We're hitting all of the really important protocols now. Internet Control Message Protocol. ICMP has many legitimate uses. However, ICMP functionality has been used to craft a number of types of exploits. ICMP can be used to identify hosts on a network, the structure of the network, and determine the operating systems that are in use on the network. It can also be used as a vehicle for various types of denial of service attack. Now, let's have a little look at something. Okay, we'll go back to our packet tracer. I'm just going to actually lose the packet tracer window for the moment, and you'll notice that I have running my CCNA CyberOps suite of virtual machines. So I've got the CyberOps workstation, I've got the Kali machine, the Metasploit machine, and the Security Onion. All four machines, which are used in our little sandboxed environment, all running at the moment on the system. If I go to, which one have I got here? I've got the Security Onion just there. I actually want to have a little look at the Kali machine. So let's see if I can find the Kali machine. There we go. So here is a Kali Linux machine. The VM that comes over with the course doesn't appear to have the virtual machine guest extensions installed on it, so you cannot resize the window. If I open up a terminal window, ICMP, we can actually make use of Nmap in order to scan systems. Now what I'm going to do is I'm going to see if we can scan the Metasploitable host that comes with the CyberOps. Just need to find that Metasploitable host first. Okay, bear with me a minute. For some reason or other, my windows are not wishing to select. I'm completely unable to select the windows that I should be able to select here. That's very, very odd. Don't quite understand why that's doing that. We might actually not be able to do this unless I can see if there's another way of doing this. That's very, very strange. Normally what I can do is I can cycle through my windows. I'm going to have to actually do it the old-fashioned way, using the Alt-Tab. Okay, I did find it eventually. Over here we have the Metasploitable host, which comes with the course. You can actually download it from a lab at the end of this chapter, chapter 11. It comes across as a OVA file, which you can just import into VirtualBox. I'm going to do an IPA to see what IP address I have on here. I have the IP address 209.165.200.235. I'll have a little look at our Kali Linux machine to see what IP address we have on there. 209.165.201.17, so they're both on the 209.165.200 network, which is good. So actually no, they're not. This is on 201. Okay, I think these are actually on different networks. What I'll do is, rather than mess about with these, it'll be a lot quicker to simply bring up yet another virtual machine. You rehearse these videos again and again, and sooner or later something's always going to go wrong. There we go. Let's bring up a completely different one that's connected out to the internet, and we'll actually do a little scan of my home network. just want to show to you just the power of the ICMP protocol. Okay, this is a Kali Linux machine. This is the very latest version of Kali Linux, the one that came out about a week ago. I've downloaded this. I've also installed the virtual guest editions on this one, so we can resize the screen. You cannot play enough with these virtual machines and these Linux distributions for a security course. The more you can get your students using these, the better. Okay, I'm going to bring up the terminal window and we'll do an IPA. This will be on my home network of 192.168. It's not, you know, it's on 192.168.56.103, and I know why. I know exactly why. Okay, we're having a bit of fun with Linux now. Network, you'll notice that I'm on the host only adapter. I'm going to set that to the bridged adapter, bridge it to my wired network card. Okay, and then we'll go back into Kali, but not and that's the wrong Kali, that one. Okay, should you need to get your computer to obtain an IP address from a DHCP server, my router in my house will work as a DHCP server. You can do a DH client. The -v basically means verbose, so show me what's happening on ETH0, and you'll notice that it sends out what's known as the DORA, discover, offer, request, acknowledge, which is the standard DHCP messaging. And you can see I've now got an IP address of 5052. So I'm on my home network now. And now what we'll do is we'll do an nmap -sv -O -T5 of my home network. I'll scan the entire network, see what happens. -sv is a stealth version scan, so this will look for any listening ports that are open on the computers, on the targets. It will report that the port is open if it is indeed open and there is a network application listening behind that port. It will also try to give us the version of the application that is listening behind that port. -O is an operating system fingerprint, so it will try to determine the operating system that is on the target machine. The -T5 will just allow us to get the scan back faster because it doesn't worry about down filter ports. And then what I've specified my entire home network on A/24 mask. Now that might take a little while, so while that's actually doing that, we'll go back. Whoa. Okay, ladies and gentlemen, it's definitely going to be one of those days today. We've had a segmentation fault, so that basically means that nmap has failed. Let's just try doing a ping scan for a minute. I'll just see if nmap fails again. It's managed to do a ping scan okay. So let's just focus in on something. What I'll do is I'll focus in on the Seiko Epsom here. The fact that it's looked at the MAC address, it's took the first 24 bits of the MAC address and then reversed those to work out, interrogated those to work out who the manufacturer is that owns the first 24 bits of the MAC address. In this case it's Seiko Epsom, which makes me think of course it's a printer. It is indeed a printer because that is my printer's IP address. However, to confirm things, what I can do is I can run the version and operating system scan against that device. Hopefully it won't do a segmentation fault again, and it might return some information about the capabilities of that device. There we go, that's what I was looking for. Okay, so it's basically telling me port 80 is open, There you go, Epsom stylus, printer, universal plug and play, very dangerous protocol, universal plug and play, and numerous other ports are open. The fact that port 80 is open would mean that we could go into that device using a web browser. Internet, Firefox. Okay. Yeah, so there you go. This gives you some idea of the power of a simple network scan. So ICMP can indeed be used to identify hosts on a network, the structure of the network, and determine the operating systems that are in use on that network. It can also be used as a vehicle for various types of denial of service attack. It can also be used indeed for data exfiltration through ICMP traffic from the inside of a network. Access control lists. So access control lists may indeed provide a false sense of security. Many technologies and protocols have impacts upon security monitoring, and access control lists are among these technologies. Access control lists and packet filtering in general are technologies which contribute to an evolving set of network security protections. Now the thing is, it's relatively straightforward for an attacker to determine which IP addresses, which protocols and which ports are actually allowed by an access control list. This can be done either by port scanning or by penetration testing or through other forms of reconnaissance. The attackers can then craft packets which use spoofed source IP addresses, and applications can actually establish connections on arbitrary ports. So there are indeed ways of getting around a packet filtering, firewall or access control lists. Network address translation and port address translation. These can also complicate security monitoring. Multiple IP addresses are mapped to one or more public address that's visible on the internet. With port address translation, we can actually have many internal or inside IP addresses mapped across to a single outside IP address, which is supplied by the service provider. Both NAT and PAT, port address translation, will hide the individual IP addresses that are on the inside of the network. Now, this problem can be especially relevant with what's known as NetFlow, Cisco's NetFlow data. NetFlows are unidirectional and are defined by the addresses and the ports that they share. So NAT will essentially break a flow that passes through a NAT gateway, making flow information beyond that point unavailable. Cisco offers security products that will stitch flows together even if the IP addresses have been replaced by NAT. Okay, encryption. As was mentioned with Hypertext Transfer Protocol Secure, HTTPS, encryption can prevent challenges to security monitoring by making packet details unreadable. Encryption is a part of VPN technologies. In a VPN, a commonplace protocol like IP is used to carry encrypted traffic. Encrypted traffic essentially establishes a virtual point-to-point connection between networks over a public facility. Encryption makes traffic unreadable to other devices except for the VPN endpoints. A similar technology can be used to create virtual point-to-point connection between internal hosts and a threat actor's device. Malware can establish an encrypted tunnel that rides on a common and trusted protocol and uses it to exfiltrate data from the network. Peer-to-peer network activity. In peer-to-peer networking, hosts operate as both clients and server roles. There are three types of peer-to-peer applications existing. These are file sharing, processor sharing, and instant messaging. In a file sharing peer-to-peer, files on the participating machines are shared with members of peer-to-peer networks. So examples of these are the old Napster and Nutella. Bitcoin is a peer-to-peer operation that involves sharing of a distributed database or ledger that records the Bitcoin balances and transactions. And of course, BitTorrent is a peer-to-peer file sharing network. Any time that unknown users are provided with access to network resources, security is a concern. Security is compromised. File sharing peer-to-peer applications should never be allowed on corporate networks. Peer-to-peer network activity can circumvent firewall protections and is a common vector for the spread of malware. Peer-to-peer is inherently dynamic. It can operate by connecting to numerous destination IP addresses, and it can also use dynamic port numbering. Shared files are often infected with malware, and threat actors can position their malware on peer-to-peer clients for distribution to other users. In processor sharing peer-to-peer networks, donate processor cycles to distributed computational tasks. So for instance, research into cancer, searching for extraterrestrial life, the old SETI, scientific research use donated processor cycles to distribute computational tasks. Instant messaging is also considered to be a peer-to-peer application. Whilst instant messaging has legitimate value within organisations that are have geographically distributed project teams, in that particular case, however, specialised instant messaging applications are available, such as Cisco's Jabber platform, which are much more secure than the instant messaging that's used on public servers. Tor, the Onion Router. This is a software platform and a network of peer-to-peer hosts that function as internet routers on the Tor network. Now, the Tor network allows users to browse the internet anonymously. Users access the Tor network by using special browser. When browsing session is begun, the browser constructs a layered end-to-end path across the Tor server network. This is encrypted. Each encrypted layer is peeled away like the layers of an onion, hence the term onion routing, as the traffic traverses a Tor relay. The layers contain encrypted next hop information that can only be read by the router that needs that information. In this way, no single device knows the entire path to the destination, and routed information is readable only by the device that requires it. Finally, at the end of the Tor path, the traffic reaches its internet destination. When the traffic is returned to the source, an encrypted layered path is again constructed. So Tor prevents a number of challenges to cybersecurity analysts. First, Tor is widely used by criminal organizations on the darknet. In addition, Tor has been used as a communications channel for malware command and control. Because the destination IP address of Tor traffic is obfuscated by encryption, with only the next hop Tor node being known, Tor traffic avoids blacklists that have been configured on security devices. Load balancing. So load balancing involves the distribution of traffic between network paths in order to prevent overloading network resources with too much traffic. If a redundant resource exists, a load balancing algorithm or device will work to distribute traffic between those resources. One way this is done on the internet is through various techniques that use DNS to send traffic to resources that have the same domain name but multiple IP addresses. In some cases, the distribution may be also to servers that are distributed geographically. This can result in a single internet transaction being represented by multiple IP addresses on incoming packets. This may cause suspicious features to appear in packet captures. In addition, some load balancing managers or LBM devices use probes to test the performance of different paths and the health of different devices. So an LBM may send probes to different servers that is load balancing traffic in order to detect that those servers are operating. This is done to avoid sending traffic to the resource that is not available. These probes can appear to be suspicious traffic if the cyber security analyst is not aware that this traffic is part of the operation of the LBM. Okay, alert data. Now, alert data consists of messages generated by IPSs, intrusion prevention systems, or IDSs, intrusion detection systems, in response to traffic that violates a rule or matches the signature of a known exploit. A network intrusion detection system, or NIDS, such as Snort, come configured with rules for known exploits. The alerts are generated by Snort and are made readable and searchable by applications such as Snorby or Squeal, which are part of the Security Onion suite of network security monitoring tools. Now, I wonder if I can find the Security Onion to show you. Yeah, I think I found it. Okay, so the Security Onion, this is the one that comes over on the course. Again, obtainable as a .ova file. Simply import into VirtualBox. You need to play around with the settings of the virtual network adapters, but you only really need to do that on the cybersecurity workstation host. We can see on here that, let's have a little look. I'm just trying to find the terminal window. There we go. Terminal emulator. That's the only thing with Linux. You've got that many different distributions. Everything's always in a different place when you go to look for it. We actually have on the Security Onion no less than 4 Ethernet cards. So this works as a router which connects other virtual machines together, among other things. Squeal. Which is used to make the alerts from intrusion detection systems and intrusion prevention systems, such as Snort, easier to read. Squeal runs on the local host on port 7743, and we just need to type in the username, analyst, and the password, CyberOps. Okay, and then we can click on which Ethernet ports we wish to monitor. We'll select all ports, I think. Start Squeal. Okay, we can actually see that we've actually got some real-time events already coming up on the system. Snort statistics. Very, very powerful piece of software. Okay, so we can see Squeal actually on this slide. So alerts generated by Snort or other intrusion detection systems can be made readable and searchable by applications such as Squeal, which is part of our Security Onion of network security monitoring tools. Session and transaction data. So session data is a record of a conversation between two network endpoints. More often than not, a client and a server. The server could be inside the enterprise network or at a location accessed over the internet. Session data is data about the session. It's not the data retrieved and used by the client. So session data will include identifying information such as the 5 tuples of the source and destination IP address, the source and destination port number, and the IP code for the protocol in use. Data about the session typically includes the session ID, the amount of data transferred by the source and destination, and the information related to the duration of the session. BRO is a security monitoring tool that we will use in the labs. BRO should be on, I believe it's on the Security Onion, if I remember correctly. Okay, full packet captures. Full packet captures, these are the most detailed network data that is generally collected. Because the amount of detail, they're also the most storage and retrieval intensive types of data used in network security monitoring. So full packet captures capture not only the data about network conversations, like session data, but a full packet capture contains the actual contents of the conversation itself. So Wireshark, for instance, if you're running a voice over IP network and you actually run Wireshark to capture those packets, it is indeed possible with most codecs to very simply reassemble those packets and pull out the audio information from the voice over IP session. You can literally listen to the phone call via Wireshark. Now, I'm not going to bother firing up Wireshark because I'm pretty certain that everybody has seen Wireshark at some point or other when we've been doing these videos, or before. Statistical data. So like session data, statistical data is about the network traffic. Statistical data is created through the analysis of other forms of network data. And from this analysis, conclusions can be made that describe or predict network behavior. Statistical characteristics of normal network behavior can be compared to the current network traffic in order to detect any anomalies. Statistics can be used to characterize normal amounts of variation in a network traffic pattern in order to identify network conditions that are significantly outside of these ranges. Statistically significant differences should then raise alarms and prompt investigation. So network behavior analysis and network behavior anomaly detection are approaches to network security monitoring that use advanced analytical techniques to analyze net flow or internet protocol flow information. Techniques such as predictive analytics and artificial intelligence perform advanced analysis of detailed session data to detect any potential security incidents. An example of a network security monitoring tool that utilizes statistical analysis is Cisco's Cognitive Threat Analytics. This is able to find malicious activity that has bypassed security controls or entered through an unmonitored channel, including removable media. And it's operated inside the organization's environment. So Cognitive Threat Analytics is a cloud-based product that uses machine learning and statistical modeling of networks. It creates a baseline of the traffic in the network and it identifies any anomalies. It analyzes user and device behavior and web traffic to discover command and control communications, data exfiltration, and potentially unwanted applications operating in the infrastructure. Host logs. Now, as we mentioned earlier, a host-based intrusion prevention system runs on individual hosts. Host-based intrusion prevention systems or intrusion detection systems not only detect intrusions, but in the form of a host-based firewall, they can also prevent intrusion. Now, this software creates logs and stores them on the host. This can make it difficult to get a view of what is happening on hosts in the enterprise. So many host-based protections have a way to submit logs to a centralized log management server. In that way, the logs can be searched from a central location using NSM tools. So, HID systems can use agents running locally on the computers in order to submit logs to a management server. OSEC is a popular open source HIDS, and this includes robust log collection and analysis functionality. In fact, Microsoft Windows includes several methods for automating host log collection and analysis. Tripwire is a HIDS for Linux, which includes similar functionality. All of them can scale to larger enterprises. Microsoft Windows hosts are visible locally through the event viewer, and the event viewer keeps 4 types of logs. It keeps application logs. These contain events logged by various applications. System logs. These include events regarding the operation of drivers, processes and hardware. Setup logs. These record information about the installation of software, including Windows updates. And finally, security logs. These record events related to security, such as login attempts and operations related to the file or object management and access. Right, moving round almost in a circle, we're back on Syslog again. Now, Syslog includes specifications for message formats. It's a client-server application structure and network protocol. Many different types of network devices could be configured to use the Syslog standard in order to log events to a centralized Syslog server. Because Syslog is a client-server protocol, Syslog in fact is defined within the Syslog working group. This was the Internet Engineering Task Force, the IETF, request for comment 5424, and it's supported by a wide variety of devices. The Syslog sender sends a small, it's less than 1 kilobyte, text message to the Syslog receiver. The Syslog receiver is commonly called Syslog D, short for Syslog daemon, daemon being a software server. And the Syslog messages would be sent via UDP port 514 or sometimes by TCP, typically port 5000. Whilst there are some exceptions, such as SSL wrappers, this data is generally sent plain text across the network. The full format of a Syslog message can be seen in the diagram here. This consists of a priority, a header, and a message text. Now, the priority consists of 2 elements, the faculty and the severity of the message, which are both integer values. The faculty consists of a broad category of sources that generated the message, such as a system, a process, or an application. The faculty value can be used by the login server to direct the messages to the appropriate log file, whilst the severity of the message, this is what ranges from 0 to 7, and this defines the severity of the message. The severity would run from emergency, alert, critical, error, warning, notification, and informational. The priority value is calculated by multiplying the faculty value by 8 and then adding it to the severity. Let's see if we can see this in the next slide. So here we are, we can see our severity, E, A, C, E, W, N, I, and in fact there's one missing off the bottom there really, which is our debugging, which is integer number 7. We've got our faculty messages, kernel, user, mail, daemon, etc. So in order to calculate a priority value, we multiply the faculty value by 8 and then add it to the severity value. The priority value is the first value in a packet, and it occurs between the angled brackets. The header section of the message contains the timestamp. If the timestamp is preceded by a period or an asterisk symbol, a problem is indicated with NTP. The message portion contains the meaning of the Syslog message, and this can vary between device manufacturers, and it can be customized as well. And it's this portion of the message that is the most meaningful and the most useful to the cybersecurity analyst. Let's have a little look what we got here. So server logs. So server logs are essential sources of data for network security monitoring. Network application servers such as emails and web servers keep access and error logs. Especially important are the DNS proxy server logs. These document all the DNS queries and responses that occur on the network. Now, DNS proxy logs are very useful for identifying hosts that may have visited dangerous websites, or for identifying DNS data exfiltration and connections to malware command and control servers. Many Unix and Linux servers make use of Syslog. Others may use proprietary logging. The contents of the log file events depends upon the type of server. Two very important log files to be familiar with are the Apache Web Server Access Logs and the Microsoft Internet Information Server, or IIS, Access Logs. We have a little look at the Apache Web Server Access Log. The Apache Web Server Access Log records requests for resources from clients to the server. The logs could be in one of two formats. The first is what's known as CLF, or common log format. The second is the combined log format, which unfortunately would have the same same set of abbreviations there, wouldn't it? The fields in the Apache Access Log in the CLF are as follows. We have the IP address of the requesting host, the identity of the client, the user ID, the timestamp, the request, which is the request method, the requested resource and the requested protocol, and then the status code. Status code being a 3-digit numeric code representing the status of the request. Codes beginning with a 2 represent success, such as 200. For instance, HTTP success code 200. Yeah. Codes that begin with a 3 represent a redirection, and codes that begin with a 4 represent client errors. Old famous 404 file not found and things like that. Codes that begin with a 5 represent server errors. Looking at the Microsoft Internet Information Server, this creates access logs that can be viewed from the server by using Event Viewer. Event Viewer makes viewing the native IIS log format much easier. An ASCII text example of raw log file entries with explanations of the fields is shown in this figure. The native IIS log format is not customizable. However, IIS can log in more standard formats such as the W3C extended format, and this does allow customization. Okay. The Security Information Event Manager, or SIEM technology. This is used in many organizations to provide real-time reporting and long-term analysis of security events. SIEM combines the essential functions of Security Event Manager and Security Information Manager tools to provide a comprehensive view of the enterprise network using the following features. Log collection. These events, event records from sources throughout the organization and provide important forensic information to help address compliance reporting requirements. Normalization. This maps log messages from different systems into a common data model, enabling an organization to connect and analyze related events, even if they were initially logged in different source formats. Correlation. This links logs and events from disparate systems and applications, speeding the detection and the reaction to security threats. Aggregation. This reduces the volume of event data by consolidating duplicate event records. Reporting. This presents correlated aggregated event data in real-time monitoring and long-term summaries, including graphically interactive dashboards. And compliance. This is reporting to satisfy the requirements of various compliance regulations. Now, a popular SIEM or SEIM is Splunk, which is made by a Cisco partner. TCP dump. Hey, good old TCP dump. TCP dump is a command line tool. It's a very popular packet analyzer. It can display packet captures in real time or write packet captures to a file. It captures detailed packet protocol and content data. In fact, Wireshark is a graphical user interface built upon TCP dump's functionalities. So if we were to have a little look at, let's bring up terminal window. And this is on my main machine. So if we do a TCP dump, which is obviously not installed, this is a Manjaro Linux machine. Let's see if I can install TCP dump on here. It should be possible to do so. Command line based packet capture. I think I'm very nearly breaking this computer. I've got 5 virtual machines running, streaming, half a dozen web browsers running, and it's still going. It's still going. Good old machine. Okay, let's see if it can do it. TCP dump. Powerful command line packet analyzer. Install. Apply. Password. Okay, whilst that installs TCP dump, let's continue because we're getting toward the end of the presentation now. NetFlow is a protocol used for network troubleshooting and session accounting. This is a Cisco protocol. It provides network traffic accounting, usage-based network billing, network planning, security, denial of service monitoring capabilities, and network monitoring. It provides information about network users, applications, peak usage times, and traffic and routing. There is a NetFlow packet tracer lab as part of this chapter, which is quite interesting. Application visibility and control. So Cisco's application visibility and control system combines multiple technologies to recognize, analyze, control over 1,000 applications. These include voice and video, email, file sharing, gaming, peer-to-peer, and cloud-based applications. It makes use of Cisco's next-generation network-based application recognition in order to discover and classify the applications that are in use on the network. NBAR 2, that's network-based application recognition, 2 recognizes will actually support over 1,000 network applications. Very, very powerful piece of software. There is a video link on section 11.233 where they will explain precisely what Cisco application visibility and control can do, and it is an extremely powerful tool. Content filtering logs, so devices that provide content filtering such as Cisco's email security appliance and their web security appliance provide a wide range of functionalities for security monitoring. Logging is available in many of these functionalities. So the ESA, for instance, the email security appliance, has more than 30 logs that can be used to monitor most aspects of email delivery, system functionality, antivirus, anti-spam, blacklist and whitelist decisions. Most of these logs are stored as text files and can be collected on Syslog servers or can be pushed to an FTP or SCP, Secure Copy Protocol server. In addition, alerts regarding the functionality of the appliance itself and its subsystems can be monitored by email and sent to administrators who are responsible for monitoring and operating the device. WSA offers a similar level of functionality. So, logging from Cisco devices. Cisco devices can be configured to submit logs and alerts using SNMP or Syslog. We actually, in Packet Tracer, right near the start of this session, configured a router in order to log to a Syslog server. Very straightforward to do, as long as you have IP connectivity to that device. It's simply a matter of going into global configuration mode, typing login, followed by the IP address of the Syslog server, and then setting your trap level, which will set the severity level. In Packet Tracer you can only set it to debugging or severity level number 7, which of course will do all the ones below it. Proxy logs. Now a proxy log excuse me, these are used for web and DNS requests. They contain valuable logs which are a primary source of data for network security monitoring. So proxy servers, interesting. Hold on a second. I think that might just possibly have got round to installing TCP dump now. Proxy servers are devices that act as intermediaries for network clients. So, for example, an enterprise may configure a web proxy to handle web requests on behalf of clients instead of the requests for web resources being sent directly to the server from the client. The requests are sent to the proxy server first. The proxy server then will request the resources and return them to the client. The proxy server will generate logs of all requests and responses, and these logs can be analyzed to determine which hosts are making the requests and whether the destinations are safe or potentially malicious, and also to gain insights into the kinds of resources that have been downloaded. Squid is an example of a proxy server. OpenDNS, this is a Cisco company, offers a hosted DNS service that extends the capabilities of DNS to include security enhancements. Here we go. Transaction successfully finished. So we'll have a very quick look at TCP dump in a moment. Next generation intrusion prevention system devices. These will extend network security right up to the application layer and beyond. So we're talking about firepower. Firepower can be run on Cisco ASA firewalls as well. So common next generation intrusion prevention system events include the connection event, the intrusion event, and the host and endpoint event, network discovery event, and the net flow event. Okay, one last thing to have a quick look at. Okay, transaction successfully finished. Excellent. So that means we have TCP dump installed. Yep, that's good. Okay, so all I need to do now is bring up a terminal window, and let's see what TCP dump's got to say. We can specify that we want to monitor the interface Ethernet 0. This could be interesting because that's the one I'm streaming from. Aha! Need to be the root user, so I'll just do an SU. Tap in my long and secure root user password, and this could be very interesting. Let's hope it doesn't break everything, because there's going to be quite a lot of packets flowing through this interface, I would imagine. Ethernet 0. No such device exists. Of course it's not called Ethernet 0 on this system, is it? It is called EN01. Okay, so whoa, lots of stuff. Let's stop that. So within a fraction of a second there, we've got 1,155 packets captured. We've actually dropped quite a few packets as well. Oh, actually, there was only 25 packets captured. If you look at that, lots of packets received, lots of packets dropped. That may indeed be because of the sheer amount of traffic that's flowing through, or perhaps just the fact that I've used a very simple settings there. We can see quite a lot of information going to Facebook here, and return traffic going the other way. Yep, there's quite a lot of information there that can be quite useful for working out what is actually going on with traffic flowing around your network. Okay, that is actually the end of the security monitoring chapter, chapter 11. Chapter 12, next week, we'll look at intrusion data analysis. So join me next week on the 9th of December at 2000 hours for intrusion data analysis. I like that one, Tim. If my computer can't handle it, it's a pretty good computer. It's not desperately old, no, but it does the business. Okay, that's not the most exciting of chapters, but I hope you found it interesting, and I will see you next week for chapter 12, intrusion data analysis. Thank you very much, my friends. Signing out.